So this should be a pretty short lecture on scientific notation. Again, this is something you guys should already know, but I want to at least give you my tips and tricks, if there is such a thing, on how to easily understand scientific notation. Nope. So it bears mentioning the why behind scientific notation. Why do we use scientific notation? There's two real reasons I'm looking for here that I think of when I think of why on earth do we have to write something in scientific notation. What's one of them?
So we don't waste our time.
What do you mean waste your time? I agree, but what do you mean waste your time? Yes, exactly, right? This number here, you had to write that a bunch of times. A, it's time consuming. B, there's maybe a margin of error where, oh, I forgot 1 0, or I put 1 extra 0, or whatever. Right? Writing giant numbers is the worst. Alternatively, writing little numbers is also terrible. Right? It could just as easily be this. Same thing. That's a terrible number to have to write over and over and over. All those zeros and whatever it is. Right? So that's one of the big reasons that scientific notation is nice. For really, really huge numbers, really, really small numbers, it's absolutely great to, I don't know that saving space is that important. Right? But ultimately, it's a much more concise and clean way to list a giant or a small number. What else? And this was kind of hinted at in the pretest we did yesterday, is also a feature of scientific notation. I'll give you a hint. It has to do with significant figures. Why is scientific notation good when it comes to sig figs?
You should only use the amount of digits in the answer as in the original.
Kind of. So that's a sig fig rule, yes. But the beauty of scientific notation, whatever your number is, that number is represented in scientific notation. You don't have to guess. You don't have to remember the rules. You don't have to do anything to figure out sig figs in this number. Right? You just have to literally count how many digits are in the sig fig. This is 3. Are there ever going to be leading digits, leading zeros in a scientific notation number? No. You're never going to have 0.000043. The format for scientific notation is never going to have leading zeros. Are you ever going to have trailing zeros in scientific notation? 15 or 16 zeros at the end of a number. Are you ever going to have that in scientific notation? No. So it automatically eliminates insignificant digits. So if you need significance, here it is. Further, while we're just talking about that, let's say you have some number. 15. How many sig figs in that number? 2. We all agree on 2, right?
Yep.
What if I want to represent that number with 3 sig figs?
You shouldn't. Oh, you could put decimal.
No, because if you did this, right now how many sig figs? No, that's not a good decimal. If you did this, now how many sig figs? 4. Well, I want 3. I don't have 4 sig figs, I only have 3. This becomes a problem with standard notation, with just a number. How do I represent this number with 3 sig figs? Well, if I do it with scientific notation, it gets super easy. Right? Now, how many sig figs does this number have? 3. And you don't even have to wonder about it. You don't have to mess with counting it. If there's 3 digits in your number for scientific notation, you have 3 sig figs. It lets you do this. There's really no good way to represent this number in standard notation with 3 sig figs. Sometimes you'll see stuff like a bar above it or other things. Just use scientific notation to make it easy. So now let's go through some examples of how to actually do scientific notation from regular numbers. So my method, is this a big number or a small number? It's a big number. Okay, so keep that in mind. What is our number going to be in standard scientific notation here? The format? 7.83, right? Number, point, number, however many it is. You get rid of those trailing zeros. And what's the last thing you have to do here? Times 10 to the what? How do we determine what number goes in that exponent for the 10? Yeah, how many times you move the decimal? It's super easy, right? So the decimal started here. 1, 2, 3, 4, 5. It is a big number, so that exponent is positive. And poof, we have scientific notation. Sig figs is the right. 3 and 3. We are good to go. Small numbers. Same thing. What's going to be my number format here? 5.61 times 10. How many times do we move the decimal? 5 times. Is it a big number or small number? Small number, negative exponent. And that's really it. Going the other way. So sometimes you start with scientific notation, you want to move backwards the other way and put it into standard notation. Right? Is this going to be a big number or small number? Going to be a big number. Okay? So again, I don't focus on memorizing left and right, but now I can look at this number and say, well, I want to turn this number, this reasonably sized number, into a big number. Yes, sir? Oh, yeah. Sure. So I want to turn this into a big number. So now looking at it, how do I turn this into a big number? Which way is that decimal going to go? To the right. How many times?
7.
I'm going to rewrite this so I have room. 1, 2, 3, 4, 5, 6, 7. Put in some zeros. I guess I'm going to rewrite this. 8, 9, 2, 1. 1, 2, 3, 4. Maybe put in some commas to make it legible, and you have your standard notation for this. Again, this is obviously pretty simple stuff. Climber, do I really need to write those little swirls, swoops, whatever, under the thing? Do I have to do that? Do you have to do that? No. Can you do that? Sure. If you want to make sure you get it right, do that. That's fine. Once you've done a gazillion of these, you probably won't need to anymore. Right? But for now, yeah, however you have to do it, rewrite it, add some extra stuff in there, whatever. Let's do a small number. So, is this going to be a big number or a small number? Small number. Which way do we have to move the decimal to make this number smaller? And we have to move it 1, 2, 3 times. 0, 0, 8, 3, 2 is our number. So that's it. Obviously, you guys, no real magic to this. But we took a pretest on it yesterday, and many of you did not do very well on it. So this is our chance to review. And like I said, we'll go through this over and over and over again, making sure that we get it right. Just some corner cases. How do I write that number in scientific notation? And to your point, why would you? It's already a nice, clear, concise, easy to write number. The sig figs are 3. Why would I need to write that in scientific notation? The short answer is, well, you might not need to. Right? But if I'm asking you, hey, write that number, represent it in scientific notation, how could we do that? Times 10 to the 0. Just do what you did on every other one. Okay? Rewrite the number in the right format. Number, dot, number, number, number. There it is. How many times do we have to move the decimal to get it there? We didn't have to move the decimal. We moved it 0 times. So times 10 to the 0. Algebraically, what does times 10 to the 0 resolve to? 1. So something times 1 is just itself. Alternatively, obviously, if you're given this, and you need to move that to standard notation, you just get rid of the times 10 to the 0. And you're done. Any questions on this? I know this is pretty standard stuff. This is a short one. But again, we spent much more time on it in the past.